Hi everyone. Today we're going to be talking about determining the y-intercept from tables, graphs, and equations. Let's make sure that everybody understands what a y-intercept is. Please put this vocabulary term into your critical concepts section of your binder. The y-intercept is the point where a linear graph crosses the y-axis. For our purposes, the y-intercept will always be written as an ordered pair in the form 0, y, meaning 0, whatever the y-intercept is. Here are two graphs that we can look at as an example. You can see the graph on the left. There is a red arrow pointing to where the purple line is crossing the y-axis. The purple line is crossing at the point 0, 2. Now, the graph on the right, you can see the red line. The red line is crossing the y-axis at the point -1. When we write that in ordered pair form, that would be 0, -1. All right, right now we're going to take a look at how to find the y-intercept from a linear relation given in a table. At this time, please pause the video and go get your textbook. Open up to page 189, where we'll be focusing on problem 3, determining the y-intercept from a table. If you already have your book open, great, let's move forward. Okay, in this table I can see the x values, 200, 225, 250, etc. And those x values are increasing. However, if we want to find the y-intercept, which we know is going to be to the point 0 in the x value and whatever our y-intercept is, I want to take this table and I actually want to rearrange it. So I'm going to rewrite my table, and I'm going to ask you to do the same, either in the space next to the table or in your notes. We're going to start with the lowest value, 300, which has a y value of 22. Then we'll move on to 275, 20, etc. Okay, so I filled in the rest of the values from the table, and now I can see my x values are decreasing, which will allow me to continue to decrease until I get to the x value of 0, which is what we need for our y-intercept. When I look at my x values, I can see that these values are decreasing by 25 each time. So 300 minus 25 gives me 275. 275 minus 25 gives me 250, etc. So if I would like to continue the pattern, I'm going to continue with 200 minus 25, which gives me 175. Continuing to subtract by 25, I'm going to continue all the way down till I get to 0. Now when I look at my y's are decreasing by 2 each time. So in order for me to continue to extend the pattern here, I'm going to have to subtract by 2 over and over again until I get down to that 0x value, so that I'll know my y-intercept. Please go ahead and do that now. So when all is said and done, it looks like our y-intercept is going to be the point 0, -2. We're going to make sure that we write that in coordinate form. At this time, please pause your video and go to the top of page 190, where you will complete problem number 2, finding the y-intercept from a table. When you're done with that problem, resume the video. All right, let's take a look at finding the y-intercept from a graph. Finding the y-intercept from a graph can be very similar to finding y-intercept from a table. We can make ourselves an xy table, and we will use the points that are located on the graph as our coordinates for the table. I am always going to start with the the point that is farthest to the right because it will have a greater x value. So right here, this is going to be our number 1 point. That point has the coordinates of an x value 80 and our y value is 15. Okay, we can see that from our x and y axes. Okay, our second point up here, which is farther to the left, so that's why it's going to be our second point, has coordinates of 60, 40. Okay, in order to continue our pattern and get ourselves down to 0, comma, whatever it might be, so we can find our y-intercept, we're going to have to extend this pattern. It looks like our x value is decreasing by 20 each time. So I'm going to subtract 20 to get 40. Subtract 20 again, that'll give me 20. And then 20 minus 20 brings me to 0. And I know that's where my y-intercept point will be. Now, while that's happening, our y values are increasing by 25. So in order to find our next y value, we'll have to take 40 plus 25, and that'll give us 65. To find the next one, we will again add 25, which will give us 90, and adding 25 one more time will get us to our y-intercept point. And 90 plus 25 is 115. So, if I write this in coordinate form, my y-intercept is 0, comma, 115. Done. At this time, please pause your video and do problem number 3 from page 189. Looks like this. When you're done, you can resume your video. Okay, ladies and gentlemen, the last thing we're going to do is take a look at finding the y-intercept from an equation. These problems are from page 192 in your book. We're going to do problems 2 and 3 together. Now, this skill is actually pretty easy because we already know that the equation for slope-intercept form is y equals mx plus b, and we know that b is our y-intercept point. So basically what this tells us is that if we can get our equations into slope-intercept form, we should be able to visually identify b by simply looking at the equation. Okay, so our first step in this problem, number 2, is to get y by itself. Okay, in order to do that, we're going to do some inverse operations. Our first one is going to be to subtract 8x on both sides. When we subtract 8x, on the left, the 8x's cancel out, and we're going to rewrite what's left over. Be careful to make sure that you have a negative 4y is equal to negative 8x plus 225. Our next inverse operation to get y by itself will be to divide by negative 4. Now, on the right-hand side, each term will have to get divided by that negative 4. And on the left, our negative 4's will cancel out, leaving us with y by itself. On the right, negative 8x divided by negative 4 gives us 2x. And 225 divided by negative 4 will give us negative 56.25, or negative 56 1/4 if you prefer fractions. Okay, now we are now in slope-intercept form, which means we can quickly identify b and write it in coordinate form. 0, comma, negative 56.25. Done. Okay, taking a look at number 3, it looks a little more complicated, but it's really not bad at all. We know that we're going to have to do the distributive property on the right-hand side. So on the left, y plus 9 stays y plus 9, and the right will become 6x plus negative 18. Okay, now I want y by itself, so I'm going to have to get rid of that plus 9 So I'll do an inverse of minus 9. Same on the other side. My plus 9 minus 9 cancels out, and y is now by itself. On the right, I will not subtract the 9 from the 6x because they are not like terms. That means 6x comes right down here, and negative 18 minus 9, or negative 18 plus negative 9, will give us negative 27. Okay, we're now in y equals mx plus b form, slope-intercept form, and we can identify b very quickly and write it as an ordered pair in coordinate form, 0, negative 27. Done. At this time, we would like you to complete problem number 1 from page 192, and then take your notes and your book to your teacher and get your checkpoint questions checked in. Good luck, everyone.